Is it going? Yep. All right. So I just turned on the video. Those of you viewing in, we just did a review of Algebra 1. How do you add fractions? You make a least common denominator. Okay, but now we're going to go backwards. To go from here to here, we call this method decomposing it into its partial fractions. So how do you do that? Okay, pay attention now. It's all in the notes now. You guys don't have to take notes. That's why I make the notes, so you don't have to take notes. So that I told you guys this on the first day, so you just listen and you absorb. No need, right? Because it's in there. I bet you the notes is almost exactly like this, except got like different numbers, yeah? Wait, let me look. Yeah, look. Look at the note, look. It's almost exactly the same, get different numbers. Okay, now this is the thinking part. This is the hard part for most of you. This is what you have to think. What fractions do I have to add together to get this as the least common denominator? Well, wouldn't it be something over x plus 1 plus something over x plus 2? Yeah, that makes sense. Okay, now how do you figure out what those somethings are? Guess and check? Yeah, you can. But then what, you know, when you get to calculus, the book, they don't care if it comes out nice. Like, I'd like to make my answers come out nice. The book, they make A come out to like 4/7 and B is -3/7 and things like that. Who's going to even guess that, right? Like, if you were just working with integers, single-digit integers, then you could probably guess and check. So, you don't want to guess and check. So, I'm going to show you the method to do it. Okay, first step. Multiply both sides by the least common denominator to get rid of the fractions. 7x plus 10 is equal to a times x plus 2 plus b times x plus 1. Are you guys following? Now, once you get to here, there's two things you can do. The first one is called equating the coefficients. Okay, now let me explain what equating the coefficients is. This is the kind of problem they give you on the PSAT and SAT, and they do it because of this. Okay, look. If ax squared plus bx plus c is equal to 3x squared plus 4x plus 5, we can then conclude that a equals 3, b equals 4, and c equals. This is called equating the coefficients. The coefficient of x squared on the left has to equal to the coefficient of x squared on the right, right? Same thing, the coefficient of x there got to equal to the coefficient of x there. The constant here got to equal to the constant there, right? That's common sense. Okay, so watch what I do. Multiply out the right side. Gather the like terms. Okay, so here are the two x terms. If I factor out the x, what's the coefficient? A plus b. And then the two constant terms are these, so that's 2a plus b. So, equating the coefficients, just like we did over here, a plus b has to equal what? 7, right? The coefficient of x got to equal to the coefficient of x. And then 2a plus b got to equal 10. The constant got to equal to the constant. And then now all you do is solve those equations. So if I were me, what I would do is, in this case, I would line them up and subtract. A equal 3. Plug it back into this one, b equal 4. And is that what we had? See? A over this and b over that. See, we got it. Mr. Park, that's a lot, because there's no way you're going to get a problem this easy. You're probably going to have x plus 1 times x plus 2 squared, and plus other stuff. So this is just an easy problem to show you what's happening here. Now the other method is called the heavy side method. Named after the British mathematician Oliver Heaviside. Okay, now, he was pretty smart. You know what he did? He said, well, instead of doing all this, because there's a lot of algebra, and can you see that if you have more factors, then there's just more variables to solve for. So he said, you know what? I'm just going to take this equation here. I'm just going to plug in numbers. That's what he said. Any idea what a good number is? What would be a good number to plug into this equation here? No. No. Come on, you guys are honors. How about -1? Why? Why is -1 good? Because when you plug it in, this becomes 0. That's why it's good. Okay, let's do it and see what happens. Plug in -1 here. What do you get?
3.
3. Okay, good. 3 equal, plug in -1 here. What? A. Come on, if we cannot plug in -1, we just go home, cook rice again. Plug in -1 here. 0. A is 3. 1. So now that you know Oliver Heaviside, what do you think another good number is? -2, because it'll make this thing 0. So what happens when you plug in -2 here? You get -4 equals 0 minus b, therefore b equal 4. Ka-ching! Do you see why that's good? And of course, I know what you guys are thinking because I've been teaching this class for 34 years. Why would we even do this? Right? Wouldn't I just do Heaviside method the whole time? Well, I'll tell you what, Heaviside method works well when you have linear factors like this. You know what linear means, x to the first power. But then when you have second and third, fourth higher powers, it doesn't work quite as well. So when you do your homework tonight, if you just have linear factors, I would just Heaviside it all the time. But then, when you have quadratic factors in there, I'm not going to give you more than quadratic. Maybe it's better to do a hybrid of the two. What are you talking about? Okay, anyway, so the key step is this step right here. If you don't set up the problem correctly, that means you cannot get the answer at all because you didn't allow for it. So if you don't set it up correctly, you know what that is then, right? Fatal error. And you can do a whole bunch of work, but it's not going to matter. You cannot get the correct answer because you didn't set it up right. So that's why I showed you guys how to set up. See, it says setting up. I gave you like lots of examples that we're going to go over right now. And we got 7 minutes. I think that's enough. You just have to understand how fractions work. That's the problem this year. Okay, so what if you, and it doesn't matter what's on the top. Oh, by the way, look at the note on the bottom. The method of partial fractions only works on proper fractions. That means the degree of the top got to be smaller than the bottom. So what if it's not, Mr. Park? Then what you have to do is you have to do division first. Like for example, if you had x squared, let's say x squared plus 2x squared plus 3x plus 4 all over x plus 1 times x plus 2, can I just do this? A over x plus 1 plus b over x plus 2? No, you can't. This would be a fatal error. Now some of you are thinking, that's just what you should know, because what is the degree of the top? 2. What is the degree of the bottom? 2. Is 2 smaller than 2? No, so you can't do it. So what you have to do is you got to do long division first, like this. Well, you don't have to do long division. You can do synthetic if you want. Divided by x squared plus 3x plus 2. X squared goes into that 2 times. I'm just going to do this really quickly. Subtract. Okay, so when you divide this by this, you get the quotient plus the remainder over the divisor. This you can do a partial fractions on, the remainder part. Okay? So if the degree of the top is not smaller than the bottom, you have to divide first. Okay, let's get that out of the way. Okay, what about something like this? 2x plus 3 all over x plus 1 times x plus 2 times x plus 3. Okay, this is where you gotta use common sense. What fractions do I have to add together so that this will be the least common denominator? This is still easy. Something over x plus 1 plus something over x plus 2 plus something over x plus 3, correct? Yeah, okay, that's easy. But what happens when you start putting powers on these? Like I said, the numerator doesn't matter what it is. Let's leave that one. Let's put a 2 there. And let's put a 3 on that one. We call this a repeated linear factor. So when you have a linear factor raised to a power, that's called a repeated linear factor. So how do you handle that? Well, I'll show you. Okay, think about it. What do I have to add together so that this is the least common denominator? Now, since we're running out of time, I'm just going to go straight to the correct way. Something over x plus 1 plus something over x plus 2 plus something over x plus 2 squared plus something over x plus 3 plus something over x plus 3 squared plus something over x plus 3 cubed. That's how you set up the problem. Now, I know what you guys are thinking because I've been teaching this for years. Mr. Park, how come I just can't do this? Right? You guys are thinking this, right? How come it can't be this? Because since you didn't allow for this possibility, then there's no way you can get the correct answer because you didn't allow for it. You have to allow for all the possibilities. I will agree, if you make a least common denominator for this, it would be this, but since you didn't allow for this, this, and this, there's no way you can get the answer. Or for those of you who just like to memorize things, whenever you have a repeated linear factor, you have to have that power plus all the ones that come before it. See? 3, 2, 1. 2, so 2 and 1. If you don't allow for it before you start, how can you get it? So that's why if you don't set up the problem correctly, fatal error. Okay, we got 2 minutes. Let's look at the quadratic factor. Okay, what if you have x plus 1 times x squared plus 1? See, that's unfactorable, right? I'm just going to tell you already. A over x plus 1 plus bx plus c over x squared plus 1. Mr. Park, how come that can't just be a b? How come it has to be bx plus c? Because what is the degree of this? 2. And what's smaller than 2? 1 and 0. But if you don't allow for that, how can you get it if you don't allow for it? So anytime you have a quadratic factor, you have to put bx plus c, or cx plus d, or fx plus g, whatever letters you're up to. Because this works on what's the word? Gosh, I forgot the word already. Proper fractions. A proper fraction is when the degree of the top is smaller than the bottom. Okay, now what happens if you have, we got 1 minute left. What happens when you have repeated ones like this? X plus 1 cubed, x squared plus 1 squared. See, repeated linear factor, repeated quadratic factor. Okay, let me just show you already. That's the correct way to set it up. See, so whenever you have a power, you have to have that power plus everything that comes before it. 3, 2, and 1. Since this is squared, you gotta have the square and the 1. And since it's quadratic, that's why you gotta put dx plus e, fx plus g. If you have a linear factor, then you can just go a, b, c, d, and so forth. Okay? So that's why I gave you guys these notes up here so you guys can figure it out. Because if you can't set up the problem, like I said, fatal error. All right, we finished just in time. We are done. And we are done with this chapter. All right, I will see you on Wednesday. Okay, see you later. Okay, next time.